What would you do if you found out you had just 90 minutes before most of the United States disappeared under a blanket of volcanic ash? Take a second and really think about that. This isn't about a war. It's not an asteroid. It's not a nuclear attack. It's something that's been sitting quietly beneath one of America's most famous national parks. A place millions of people visit every year without giving it a second thought. Yellowstone. Most people see beautiful mountains, hot springs, and geysers. A place to hike, camp, and take family photos. Scientists see something very different. They see one of the largest supervolcanoes on Earth. And here's the part that should make all of us stop and think. The biggest concern isn't that Yellowstone is still alive. Everyone already knows it's an active volcanic system. The real concern is that it's changing. The ground has been rising and falling. Thousands of small earthquakes happen there every year. New hotspots appear. Old ones disappear. The underground system isn't sitting still. Does that mean a massive eruption is about to happen? No. Nobody can honestly say that. But it does raise a bigger question. Have we gotten so used to hearing that Yellowstone is stable that we've stopped paying attention to what scientists are actually measuring? Because history has a funny way of reminding us that nature doesn't care about our schedules. It doesn't care about borders, economies, or technology. When the Earth decides to move, we don't get a vote. So what is really happening beneath Yellowstone today? How much do scientists actually know? And if this giant ever woke up, would modern civilization be ready for what comes next? Let's take a closer look. When most people hear the word Yellowstone, they picture a beautiful national park. They think about geysers, wildlife, road trips, and family vacations. That's completely normal. But if you ask a geologist what Yellowstone is, you'll get a very different answer. They won't call it a park. They'll call it a supervolcano. And that's a big difference. A regular volcano can destroy a city or a region. A supervolcano has the potential to affect the entire planet. There are only about 20 known supervolcanoes on Earth, and Yellowstone is one of the biggest. It's also one of the most closely watched because of where it sits. The last massive eruption happened about 640,000 years ago. Before that, there were two other giant eruptions, each separated by hundreds of thousands of years. That's why people often mention the so-called 600,000-year cycle. But it's important to understand something. That number isn't a countdown. It doesn't mean Yellowstone is overdue. And it doesn't tell us exactly when another eruption could happen. Volcanoes don't follow calendars. They don't care what year it is. Scientists use those past eruptions to understand how the system has behaved over a very long time. It's one piece of the puzzle, not a prediction. So, why does Yellowstone get more attention than other supervolcanoes? It's not just because of its size. It's because of its location. It sits beneath one of the world's largest agricultural regions. A huge amount of America's wheat and other CRIAs comes from areas that could be affected if a major eruption ever happened. Millions of people also live downwind. That means the impact wouldn't stop at the park itself. Ash, climate changes, transportation, food production, and supply chains could all be affected on a massive scale. That's what makes Yellowstone different. It's not just a volcano hidden under a beautiful landscape. It's a giant natural system that scientists continue to study because they know how powerful it has been in the past. And while no one can say when it might erupt again, one thing is certain. Yellowstone is far more than just another national park. Here's where things start to get interesting. Yellowstone isn't just sitting there doing nothing. The ground is actually moving. Over the years, scientists have watched parts of the park slowly rise, then sink, then rise again. You'd never notice it if you were standing there, but satellites can. And they've been tracking these changes for decades. Then, there are the earthquakes. Not one or two. Thousands of small earthquakes happen around Yellowstone every year. Most of them are so weak that nobody feels them. On their own, they're not unusual. But together, they tell scientists one important thing. The system underneath Yellowstone is still active. Heat is changing too. Some areas are getting hotter than they used to be. New steam vents have opened. Some hot springs have changed temperature. Others have changed color or stopped behaving the way they did in the past. Even some of the famous geysers have acted differently over the years. A few have become more active, others have gone quiet. It's another reminder that what's happening underground is always changing. Then something happened that caught a lot of attention. In 2014, part of a road inside the park became so hot that the asphalt started to soften and melt. Park officials had to close the area because the ground underneath had become much hotter than expected. That doesn't mean an eruption was about to happen, but it did show that the underground heat wasn't staying in exactly the same place. Scientists have also noticed that some of the hottest areas inside Yellowstone have slowly shifted over time. The landscape is changing, even if those changes are too slow for most visitors to see. So what does all of this actually mean? That's the big question. Are these just normal ups and downs in an active volcanic system? Or are they small warning signs of something much bigger happening deep below the surface? The honest answer is that no one knows for sure. That's why Yellowstone is monitored around the clock. Scientists aren't watching because they think an eruption is about to happen tomorrow. They're watching because every new measurement helps them understand how this massive system behaves. And with a supervolcano, understanding those changes may be the only warning we'll ever get. This is where the story gets a little more complicated. Not because someone uncovered a secret, but because the data raised questions that didn't have simple answers. One of the people who has spent the most time studying Yellowstone is geologist Bob Smith from the University of Utah. He's been researching the area for decades. In 2013, during an interview with National Geographic, he made a comment that caught a lot of people's attention. He said they were seeing behavior they hadn't seen before. It wasn't a dramatic warning. He didn't say an eruption was coming. He simply pointed out that the system was acting differently than what they had observed in the past. After that, the scientific instruments kept collecting more data. Satellites continued measuring tiny changes in the ground. Seismic stations kept recording earthquakes. Researchers kept studying the magma system beneath the park. Then, in 2015, scientists published a new study using advanced seismic imaging. What they found surprised a lot of people. The magma system beneath Yellowstone appeared to be much larger than earlier models had suggested. It wasn't that a huge amount of new magma had suddenly appeared. The newer technology simply gave scientists a much clearer picture of what was already there. That discovery naturally led to more discussion. If our understanding of the underground system can change this much, what else are we still learning? Another question people often ask is why the public usually hears only a few simple numbers, like the very low annual chance of a major eruption. The answer isn't necessarily because information is being hidden. Technical reports are written for scientists. They're full of detailed measurements, uncertainties, and ongoing research. Public updates, on the other hand, are meant to explain the overall situation in a way that's easy to understand. That means a lot of technical detail never makes it into a press release, and that's where some of the debate begins. Some researchers believe those simplified updates can make Yellowstone sound quieter than the data actually looks. Others argue that sharing every small change without enough context could create unnecessary fear. Both sides are trying to solve the same problem. How do you explain an active volcanic system without either downplaying it or causing panic? That's not an easy balance. The important thing is this: the scientific data is still being collected. The research is still evolving, and our understanding of Yellowstone today is much better than it was even a decade ago. That doesn't automatically mean the volcano is getting ready to erupt. It simply means scientists are learning more about one of the most complex volcanic systems on Earth. And sometimes, the more we learn, the more questions we end up asking. To understand why Yellowstone gets so much attention, it helps to look at something that happened a long time ago. Around 74,000 years ago, a supervolcano called Toba erupted in what is now Indonesia. It wasn't just another volcanic eruption. It was one of the largest events our planet has ever seen. The explosion blasted huge amounts of ash and gas high into the atmosphere. That ash spread across thousands of miles. Sunlight was blocked. Temperatures dropped. Scientists call this a volcanic winter. For years, the climate became colder. Harvests would have been much harder, and ecosystems across the world were affected. One idea that has been discussed for years is that the Toba eruption may have pushed the human population to extremely low numbers. This is known as the Toba bottleneck hypothesis. The idea is that only a relatively small number of humans survived, and those survivors eventually became the ancestors of everyone alive today. Not every scientist agrees that Toba was the only reason for that population decline. The debate is still ongoing. But what isn't really disputed is that volcanic winters can have global consequences. That's the lesson people keep coming back to. A supervolcano doesn't have to destroy the entire planet to change life across it. It changes the climate. It changes food production. And when food becomes scarce, everything else starts to break down. Now think about Yellowstone. The comparison isn't meant to say Yellowstone is about to erupt. It's meant to show what scientists use as a reference when they study the possible effects of a supervolcano. Yellowstone sits beneath a continent that produces a huge share of the world's food. Modern society also depends on global transportation, supply chains, electricity, and constant deliveries. We're far more connected than humans were 74,000 years ago. That makes us stronger in many ways. But it also makes us more dependent on systems that have to keep working every single day. If a volcanic winter ever happened on that scale again, the biggest challenge wouldn't just be the eruption itself. It would be everything that came afterward. That's why researchers continue studying events like Toba, not because history always repeats itself, but because the past is one of the few places where we can see what a supervolcano is actually capable of doing. For years, scientists thought they had a pretty good idea of what was sitting beneath Yellowstone. The common view was that there was one large magma chamber, a few miles below the surface. That model had been around for decades. Then, in 2015, a research team from the University of Utah took a much closer look. Instead of drilling into the ground, they used something called seismic imaging. It's a lot like getting an ultrasound of the Earth. When earthquakes send waves through the ground, those waves travel at different speeds depending on what's underneath. By measuring those tiny differences, scientists can build a detailed picture of what's hidden deep below the surface. What they found surprised a lot of people. The upper magma chamber was exactly where scientists expected it to be. But beneath that, much deeper underground, they found another huge reservoir. This lower chamber stretched between about 20 and 45 kilometers below the surface. When both chambers were included, the entire magma system turned out to be about 4.5 times larger than the older model had suggested. That sounds alarming at first, but it's important to understand what the study actually said. The researchers did not say Yellowstone had suddenly filled with new magma. They didn't say an eruption had become more likely. What they said was much simpler. The lower chamber had probably been there all along. Scientists just didn't have the technology to see it clearly before. So the discovery changed our understanding of Yellowstone. Not necessarily its behavior. Even so, it raised an important question. If new technology can completely reshape what we know about the volcano beneath our feet, how much more is there still to learn? That's one reason this study received so much attention. It reminded everyone that science keeps moving forward. As better tools become available, our picture of Yellowstone becomes more detailed, and sometimes those new details challenge ideas that had been accepted for years. The 2015 study didn't predict an eruption. It didn't issue a warning. What it did was give scientists a much clearer view of one of the largest volcanic systems on Earth. And when you're studying something this massive, having a clearer picture is always a big step forward. This is the part that really makes people stop and think. Not because anyone knows this is going to happen, but because scientists have spent years building computer models to understand what could happen if Yellowstone ever had a full-scale eruption. Let's walk through that timeline. The first 90 minutes would be pure chaos. A massive eruption column could shoot high into the atmosphere. Ash would begin spreading with the jet stream. People nearby wouldn't have much time to react. The areas closest to the eruption would face the greatest danger almost immediately. About 6 hours later, the ash cloud would keep moving east. Air travel across much of North America could be disrupted because volcanic ash is extremely dangerous for jet engines. That's why planes avoid volcanic ash whenever possible. By the end of the first day, ash would continue falling across a much larger area. In places where enough ash accumulates, it could damage buildings, reduce visibility, contaminate water supplies, and make transportation much more difficult. Power systems could also be affected in some areas. By day 3, the impact would extend far beyond Yellowstone itself. According to the models discussed in the video, large parts of the country could be dealing with ash, damaged infrastructure, and major disruptions to daily life. The problem wouldn't just be the eruption, it would be everything that stopped working afterward. Then comes the first week. The ash cloud wouldn't stay over North America forever. High-altitude winds could carry fine volcanic particles across the Atlantic and into other parts of the world. At the same time, tiny sulfate particles released into the upper atmosphere could begin reducing the amount of sunlight reaching the Earth's surface. During the first month, the biggest concern would shift from the eruption itself to the climate. If enough material reached the stratosphere, global temperatures could begin to drop. Growing seasons could become shorter. Crop production could suffer. Countries might start protecting their own food supplies before exporting anything abroad. By the first year, the long-term effects could become the real challenge. Food shortages, supply chain problems, economic disruption, large population movements. According to the simulations described in the video, these secondary effects could be even more difficult to manage than the eruption itself. Of course, this is still a model. It's a scenario built from geological evidence, atmospheric research, and computer simulations. It is not a prediction that Yellowstone is about to erupt, but it does remind us of something important. A supervolcano isn't just a local disaster. If an event of that scale ever happened, the effects wouldn't stop at the park's borders. They could reach far beyond Yellowstone, affecting millions of people who have never even been there. When people think about Yellowstone, they usually picture one place on the map. But if a supervolcano ever erupted there, the story wouldn't stay in Wyoming. It would spread far beyond the United States. The first thing everyone would notice is the ash. Not lava, not explosions. Ash. Fine volcanic ash can travel thousands of miles. It gets into the air, covers roads, contaminates water, damages equipment, and makes it hard for people to breathe. And unlike ordinary dust, volcanic ash is sharp. Under a microscope, it looks more like tiny pieces of broken glass. Then there's air travel. Modern airplanes and volcanic ash don't mix. If ash gets inside a jet engine, it can melt, stick to critical parts, and cause the engine to lose power. That's why even relatively small volcanic eruptions have grounded flights in the past. An event on the scale described in these models could disrupt air travel across entire regions. Power grids could face problems too. Ash can build up on power lines and electrical equipment. If enough of it accumulates, outages become much more likely. Repairing that kind of damage isn't always quick, especially if roads and transportation are already affected. But the biggest concern probably isn't ash. It's food. Modern life depends on farms producing crops every year, and trucks delivering those crops every day. If cooler temperatures shorten growing seasons or reduce harvests, food supplies begin to tighten, and once food becomes limited, everything else starts feeling the pressure. Countries may choose to protect their own supplies first. Global trade slows down. Supply chains that normally connect the world begin to break apart. Stores don't empty because food suddenly disappears. They empty because the system that keeps shelves stocked can't keep up anymore. The economy would feel those effects almost immediately. Businesses slow down. Transportation costs rise. Basic goods become harder to move. Prices increase as supply falls behind demand. If those conditions lasted long enough, more people would be forced to leave affected areas in search of food, work, or safer living conditions. Large migrations could create new challenges for countries that are already struggling with limited resources. Again, this isn't a prediction. It's a scenario based on scientific models discussed in the video, but it highlights something that's easy to forget. In today's world, everything is connected. Food, transportation, energy, trade. If one major piece of that system is disrupted, the effects don't stay in one place. They ripple across the globe. And that's why scientists don't study Yellowstone as just another volcano. They study it because an event of that scale could affect far more than the people living nearby. This is probably the question everyone wants answered. If scientists know Yellowstone is active, why don't we just stop it? The simple answer is, we can't. As advanced as modern technology has become, there's no way to control something this massive. The magma beneath Yellowstone sits miles below the surface. It's part of a natural system that's been active for hundreds of thousands of years. We can't cool it down. We can't drain it. And we can't release the pressure little by little like letting air out of a balloon. That simply isn't possible with today's technology. So what can we do? We watch. That's really our best option. Scientists monitor Yellowstone around the clock. They use seismographs to track earthquakes. GPS stations measure tiny movements in the ground. Satellites detect changes that are impossible to see with the naked eye. They also measure gases escaping from the ground and keep an eye on changes in hot springs and geysers. All of that information helps researchers understand what the volcano is doing. But there's an important difference between monitoring and predicting. Monitoring tells us what's happening right now. Prediction is much harder. Even with all the instruments in place, no scientist can tell you the exact day, month, or year when a supervolcano might erupt. Nature doesn't work on our schedule. That's why researchers usually talk about probabilities instead of predictions. One number that's often mentioned is the estimated annual chance of a major Yellowstone eruption. According to the scientific estimates discussed in the video, it's about 1 in 700,000 in any given year. That's a very small number. At the same time, scientists continue studying Yellowstone because they know volcanic systems can change over time. The goal isn't to guess the future. The goal is to recognize important changes if they happen, and maybe provide as much warning as possible. In the end, Yellowstone reminds us of something that's easy to forget. For all our technology, there are still forces on this planet that are far bigger than we are. We can measure them. We can learn from them. We can prepare as best we can, but we can't control them. Sometimes, the smartest thing we can do is keep watching, keep learning, and respect the power of the earth beneath our feet. After looking at all of this, I think one thing becomes pretty clear. The earth has never stopped changing. It was changing long before we got here, and it will keep changing long after we're gone. Sometimes we forget that. We build cities. We build highways. We create technology that makes us feel like we're in control. But underneath all of it, the planet is still doing what it's always done. Mountains rise. Fault lines move. Volcanoes stay active. Yellowstone is part of that story. Right now, there's no evidence that a massive super eruption is about to happen. That's an important point. Scientists aren't saying Yellowstone is getting ready to explode tomorrow. What they are saying is much more measured. The system is active. It's being monitored every day. Every earthquake, every shift in the ground, every change in temperature adds another piece to the puzzle. And the more we learn, the better we understand how this incredible volcanic system works. But understanding isn't the same as certainty. No one can tell us exactly when or even if a super eruption will happen in our lifetime. That's simply beyond what science can do today. Maybe that's the biggest lesson here. Human civilization has existed during a period of unusual geological stability. We've almost come to expect the ground beneath our feet to stay the same forever. History reminds us that it won't. Nature doesn't follow human timelines. It never has. That doesn't mean we should live in fear. It means we should stay curious. Keep learning. Respect the science. And remember that some of the most powerful forces on Earth are completely outside our control. So, maybe the real question isn't whether Yellowstone is dangerous. The real question is whether we truly understand the planet we live on. And I'll leave you with one final thought. The scariest part isn't knowing when Yellowstone will wake up. It's knowing that no one can say exactly when that day will come. What do you think? Are we underestimating Yellowstone? Or do you think the risk is often exaggerated? I'd love to hear your thoughts in the comments.